see ionic bond.
Okay.
And make sure this in the demo class, you look into the screen and understand, because this PDF, whatever I'm writing, I'll send it with the coordinator. You'll get.
Yeah.
Okay. So ionic bond. So what is ionic bond? Usually found in compounds that contain metal combined with non-metal. Okay, that means here we have one metal that is getting combined with non-metal. Okay, now what is a metal? A metal can be any example?
Aluminium.
Yeah, aluminium. Okay, aluminium is from alkali earth metals.
Yeah.
Okay, yeah, and there are two types of metals in the there are many types of metal, but for this combination we need group 1 and group 2 elements.
Okay.
Okay, so in group 1, this is from group 2. From group 1 we have sodium. Okay, so we'll take simple ones first to understand the concept. So sodium is the metal we are using here. Okay, plus we are going to see chlorine.
Okay.
Okay, chlorine or Cl.
Yeah.
That will get bind with each other with which form we are using in day-to-day life. Sodium plus chlorine is sodium chloride.
Yeah.
Yeah. We are going to see how it is going to get binded. Okay, I'm not like teaching this reaction for you. Okay, so what is the atomic number for sodium? Do you know it?
11, I think.
Yeah, 11, correct. Okay, 11. So, and what will be the electronic configuration? Any idea?
2, 8, and 1.
Yeah, that means you're okay with basics. Okay, you know very well basics.
Okay.
Then we have chlorine. Okay, chlorine's number is 17. Okay,
Yeah.
whatever you don't know, I'll tell you. Don't worry.
Okay.
So chlorine is 17, and what will be the configuration then? You can make it on your own.
2, 8, 8, 1.
Yeah.
2, 8, 2,
7.
8. Yeah, 2, 8, 7. My God.
Okay. Now see, there is a pattern in the periodic table. Okay, like group 1, group 2. Okay, I finished with it. So group 1 will lose 1 electron, the whole group 1. Okay, which starts with hydrogen. Correct? Yeah. And group 2, aluminium, calcium, magnesium, they will live +2. They will be oxidizing into +2 state, which is they are losing 2 electrons. What is oxidizing state of losing electrons?
Yeah.
Okay. Now, as we go from the left to right, the periodic table, so these are the 2 states of metal. Okay. Third state is for boron, boron family. Okay. Third group. In that, they will live +3. Then comes a very common thing, carbon. Okay. Carbon is +4. We know that very well. Carbon's valency is also 4. Yeah. Then we go to the further ones, that is carbon, oxygen, or nitrogen. First is nitrogen. It will at least lose 3 electrons or form 3 bonds. Okay, gain 3 electrons. And you can just memorize it. Like you will need it in every chapter. Har chapter mein lagega ye. Then we have oxygen. Okay, oxygen -2. Okay, it will only bind with 2 electrons. It will gain only 2 electrons. Okay, I'll just on my light. Okay. Okay, so we were talking about oxygen. After that comes, which we are going to use in this, that is halogens. Okay, halogens are, what are halogens?
I'm not sure.
Chlorine. Chlorine, which we are using in the reaction, is halogen. Chlorine, bromine, okay, then iodine, and then fluorine. Okay, so these are 4 of them halogens. So they have a tendency to only gain 1 electron. Okay, why? Well, there are other reasons also, like valency. Okay, are you knowing what is valency?
Yeah, the losing or gaining of electrons.
Yeah, the combining or the losing capacity of the atom, not electron. Okay, atom. Then what happens there? As per, and where are the valence electrons? There are in the outermost shell of the atomic structure. Okay, that means we are going to consider in this configuration the outermost shell as 1 and 7.
Yeah.
Understood? So, but how to find valency? I will tell you one trick, that this chlorine is, this you can memorize. But if you don't remember, okay, if you only remember the configuration, okay, you can just see the last number of the configuration, and you can, here is the 7 number. Okay, more than 4. Okay, more than 4 electrons in the outermost shell. Okay, you can minus them with 4. If any element contains in the outermost shell more than 4 electrons, so you can minus them with 8. Okay, you will get 4. This is the valency of carbon.
Yeah.
Yeah, same for here, chlorine is there. So 8 minus 7, you got 1.
1.
You can clearly see in the group 7, there is one number.
Yeah.
Okay, you can also do this. Now sodium we know it is from group 1 family, and 8 minus 1 is 7.
Yeah.
No need to do now because there are less than 4 electrons.
Yeah.
Okay, after more than 4 electrons, you can apply this trick. Now what happened next? Yeah, we are going to see how the bonding is taking place. Okay, all these were basics. Okay, now you must be refreshing your mind with basics.
Yeah.
Okay, then we'll move to the structure part. I'll just take one image here. Okay. And what is your time to study? Like at what time you study? Because you're busy with your sports and all, no?
Normally I just catch up with all of my studies in school, but during the exams, like when I come back from my classes from tennis, then I study for about an hour or an hour and a half.
And do you have physics? Like you have
Yeah,
an,
I have physics.
okay, you have. Your school has not allowed to drop it?
No, I took physics.
Acha, you took it because one of my student is not having it because she don't like it. Okay. Yeah. So this is the atomic structure. Okay. And here we can clearly see we have here the outermost shell.
Yeah.
Okay. Here is the one unpaired electron or in the 7.
Yeah.
Okay. 7 has, the stability is at 8.
Yeah.
Correct. So here is one unpaired electron, and here this is the one unpaired electron of sodium.
Yeah.
Okay. So this is the atomic structure.
Yeah.
Yeah. What are the constituents of atom? क्या क्या होता है atom में?
Protons, neutrons, and electrons.
हाँ. Okay. तो ये सारे we are talking about the electrons only now.
Yeah.
Now what will happen? Now this one electron is ready to lose
Yeah.
because it is sodium. We
Yeah.
know. Just keep in mind all the metals in the periodic table are ready to lose electrons.
Yeah.
Okay, so that will lose one electron to chlorine. And why chlorine will accept it? Because chlorine can stabilize its electronic configuration by one electron, which
Yeah.
is sodium giving. And one more thing, what is electronegativity? You know it. What is electronegativity?
No.
Okay, so that is a tendency to attract electrons towards the element itself.
Okay.
Okay, it has then like the charge or the electronegativity is form of attracting electrons towards the nucleus, this between nucleus. Okay, so chlorine has that attracting power more. Even all the halogens has that attracting power more. The electronegativity is high. Okay,
Okay.
as we go from left to right in the periodic table, the electronegativity will increase.
Okay.
Okay, so this is the thing. So it will now attract one of the electron to the chlorine side. Okay,
Yeah.
and we'll get a structure like this. Okay, what is the structure we got? The sodium has lost one electron and chlorine has gained.
Okay.
Okay, so this is the thing happening, and by this combination we have a bonding that is called as ionic bond.
Yeah.
An ionic bond contains one positively charged ion. Ion is nothing but ion. Okay,
Yeah.
what are ions? Any idea?
No.
Ions are anything that is having a charge, plus or
Okay.
minus. Okay, even
Okay.
it is plus or even it is minus, the thing is called ions.
Okay.
Okay, now the charges on the sodium and chloride ions are equal by positive, equal by opposite. So this type of bond is called as ionic bond. Okay,
Okay.
so ionic bond is a strong electrostatic attraction between oppositely charged ions.
Okay.
Got it? Now we'll take more examples. Okay. After that, we'll move to another bonding, that is covalent bonding. Now, other than sodium chloride, okay, can you tell me some metals from group 1 and halogen? I'll bind with it. Group 1 से कोई भी metal आपको याद हो तो. अच्छा, कोई metal बोल दो.
Aluminium we didn't do.
अच्छा, aluminium we can take. Okay,
Okay.
we can take. But aluminium has plus 2 state.
Okay.
No, aluminium has plus 3 state. It is from the boron family. Okay, so aluminium chloride. You must have seen AlCl3.
Yeah.
Yeah. So how this is bonding, I'll let you know now. Okay. Okay. So aluminium in its outermost shell has 3 unpaired electrons.
Okay.
Okay. And chlorine, let's take this diagram at itself for chlorine. Okay. Same. It's only having 1 unpaired electron, this one. Okay. So here aluminium, we have to take 3 of one of them. Okay. AlCl3. Okay.
Okay.
Now that means you need how many chlorines to bind with Al, aluminium, because it is ready to lose 3 electrons.
Yeah.
And chlorine is only ready to accept 1.
Yeah.
So how many chlorines you will need?
3.
Yeah. Understood the process?
Yeah.
Yeah. How much the metal is losing the electron, that many the other element will accept it.
Okay.
Okay. So chlorine will, one more chlorine I'll add over here, downward here. And I'll just make this small. You're getting what we are discussing,
Yeah.
understanding properly. If
Yeah.
not, I'll just change this understanding process. Okay. If something you're not understanding. So this is the 3 chlorine and this is the +3 structure. Okay.
Yeah.
I'm teaching as per the Cambridge syllabus. Okay. There are
Okay.
many like different types to teach this concept, but I'm teaching as per the Cambridge syllabus.
Okay.
Okay. Yeah. So same we have for calcium chloride. Calcium chloride is one of the metal.
Yeah.
Yeah. So calcium chloride will also have the same process. Okay, this is the diagram for calcium chloride. 1 calcium and 2 Cl because it has a +2 state.
Yeah.
Now I have a question. Like Mg is a metal,
Mm-hmm.
okay, and oxygen is getting binded with it.
Okay.
So what will be the thing happening here?
So it'll be magnesium oxide.
Yeah, but what about the electron exchange?
Uh,
Okay, you can go through whatever I have written here for the this thing. This table, to refer this table of electron gain and loss. You can just refer that for group 1, group 2, group 3.
I'll first need to know the atomic number of that and the outermost shell number for both of the um, atoms, and then from that, whichever one is losing electrons and gaining electrons, we'll create the table from that.
Okay, see now, I'll tell you one hint that magnesium is from +2 group 2 element.
Okay. So
And oxygen
magnesium,
also. You have to see now, oxygen can gain how many? It can gain -2.
yeah.
That means it can gain 2 electrons.
So magnesium will lose 2 electrons and oxygen will gain 2.
And what about the figures?
So it will be magnesium. What is the atomic number of magnesium?
Magnesium has 15.
And oxygen is 8, right?
8, 8.
So 15. So magnesium will be 285 and oxygen will be 8.
Yeah, that means this will be the figure for it. Okay.
Oxygen will turn into 2 and 8, and magnesium will be 2, 8, 3.
Okay. I'll just take the figure over here. What will happen?
Okay.
That means any oxygen binding with the electron, it will gain 2 electrons.
Yeah.
Okay. So it will at least need +2 state to bind, or else it will need, like if it is binding with sodium, it will need 2 sodium to bind.
Yeah.
Correct? So this was the concept. Now we'll move to the covalent bond part.
Okay.
So the questions which are coming in the exam related to this are to draw the representative diagram for the bonding process. Even they directly ask about the bonding process, like I just took for magnesium oxide.
Okay.
Okay, direct questions are coming on that, or they are asking for the molecular formula.
Okay.
I just have a table. I'll just share that with you. Okay, it will be helpful for you to learn. What chapter is going on in school?
About oxidation numbers itself.
Okay.
So learning how to calculate the oxidation number.
You're okay with it? You're not understanding.
No, we didn't start that chapter. We're going to start it now.
Okay. Oxidizing and reducing.
Yeah.
Okay. So when it comes to covalent bond, it is formed when a pair of electrons is shared between two atoms, leading to noble gas electronic configuration. Now we saw there was a transfer.
Mm-hmm.
Okay, transferred. We transferred one electron from sodium to chlorine. But now
Yeah.
what we are going to do, we are going to share the electron. Like some of the electron, some of the elements, like Cl. Cl has same electronegativity as Cl.
Yeah.
Okay, and this has a bond. So who will transfer the electron? There is a problem to transfer.
Yeah.
Okay, so here they will share one electron.
Okay.
Okay, so this is covalent bonding, in which there is a pair of electrons share between two atoms, leading to noble gas electronic configuration. Noble gas electronic configuration means stable state.
Yeah.
Yeah. What are noble gases? Any example about it?
Not really.
Neon, helium,
Yeah.
krypton. Okay, those. And this table is about oxidation numbers. Okay, and this is for the valencies also you can consider. Like lithium is having plus one all states, and magnesium you can clearly see +2. So this will help you out. Okay,
Yeah.
aluminium +3, iron +3, and here are some valencies for non-metals like halogens. Okay, even oxygen is there because oxygen has two properties, metals as well as non-metals. It's a metalloid.
Yeah.
Then group of atoms also, the valencies are given. This you'll need in the bonding process. Okay, then we'll talk about first in this thing hydrogen, H2, because hydrogen also have same number of electrons with it, 1.
Yeah.
Okay, so nobody is ready to give or transfer the electron, so here will be the sharing. And sharing looks like this. Like, I'm not drawing it because it will take a lot of time. Okay, so this is the sharing diagram. They are
Yeah.
just sharing one electron to form a bond. ऐसे दिखेगा कुछ यहाँ पे. They will like make a bond like this. Okay,
Okay.
yeah. Same for chlorine. Okay, chlorine has outermost shell. We just saw one electron. So they will also
Yeah.
share those electrons.
Okay.
That's why I took ionic bond first, because after understanding ionic bond, covalent bond is simple to understand.
Yeah.
Now we'll talk about CH4. CH4. Now carbon has the valency of 4. Hydrogen has either valence sharing electron 1. Okay, so
Yeah.
what will happen? Carbon के एक इलेक्ट्रॉन के साथ एक इलेक्ट्रॉन शेयर हो जाएगा of hydrogen.
Yeah.
So the structure will be like this. Okay, you can clearly see that hydrogen is sharing one of its electron with the carbon, and this structure is taking place.
Okay.
Okay, now clear?
Yeah.
Yeah. What about nitrogen and like ammonia, NH3? Will they share or will they transfer?
Nitrogen and
Hydrogen.
hydrogen. So hydrogen can share one, and nitrogen is can gain or lose three.
Hmm.
So they can form a structure,
Yeah,
covalent
but
structure.
covalent, correct. Covalent structure they can form. Okay, the
Yeah.
structure will be ammonia, NH3. You must have heard ammonia. The teacher must
Yeah.
have, yeah, saying that. Okay, then there are some of the structures. Okay, giant structures of ionic bonds.
Yeah.
कोई example है?
Carbon is a giant structure, right? Carbon.
हाँ, वो कार्बन का, हाँ, डायमंड ग्रेफाइट, वो
Yeah.
कोवेलेंट है.
हाँ.
कोवेलेंट होगा ना, कार्बन है उसमें. तो आई एम टॉकिंग अबाउट आयोनिक. सोडियम क्लोराइड है.
हाँ.
हाँ, so that has a ionic structure like this. ये पूछते हैं आपके एग्जाम में, that's why I'm discussing. Okay, the
Okay.
structures. So these are the structures. I have lot of question papers with me. Like I have a drive link. Whenever we'll start it, I'll just start sharing one with you so that you can refer that. Even I
Okay.
have some reference book so that you can easily learn, because sometimes what happen in your textbook, like very difficult language is given.
Yeah.
Okay, so I'll explain you properly if you're studying and you need a help, so that book can also help you. It has a very simple understanding material in it. Okay, even
Okay.
it has different types of questions also in the end.
Okay.
And 1 hour study is okay. Like if you're studying for chemistry weekly 2 or 3 days, it's fine, you can overcome it.
Okay.
Okay, so this is the thing. And see what happens in ionic structure, there is a word called lattice.
Okay.
LATTIC. देखा है कभी?
I've heard of it.
So what is this? What is the meaning of this? This is the ions are packed together in a regular arrangement. यहाँ पे in the figure you can see there is a regular arrangement. Regular मतलब same arrangement.
Okay.
Okay, called as lattice. So it is a total three-dimensional structure of that compound.
Okay.
Okay, 3D structure of that compound is called lattice. So with the lattice, oppositely charged anions attract one another strongly. Okay, and it makes a giant ionic structure.
Yeah.
सोडियम क्लोराइड देखा है ना किचन में,
हाँ.
उसका यही स्ट्रक्चर है.
Okay.
Okay, so this is the structure for that. So there are many types of structure like potassium chloride, okay, the pink salt, calcium chloride. There are many structures which are ionically bonded. Same we were talking about graphite and diamond. So they have a structure. मुझे like tell, you can just assume or you can tell on your own what will be the molecular formula for graphite and diamond.
Molecular formula?
Like NaCl. NaCl is a molecular formula of sodium chloride. NaCl. What
Okay.
will be it for graphite or diamond?
I'm not sure.
Carbon. Only C.
Okay.
Okay, because it is made up of only carbon.
Okay.
Okay, I'll just show you how they are made up of in the structure, because these structures are been asked in the papers many times.
Okay.
For covalent bonds. Okay, so see, this is one layer and this is the layer upon layer.
Yeah.
Okay, one layer is above and one layer is down. That is graphite structure.
Okay.
And when we talk about diamond, so diamond has a tetrahedral structure. Tetrahedral structure is for methane. Okay, even carbons, C4 carbon. Okay, what is the structure? This is the structure. Like this, the arrangement will be.
Yeah.
Okay, and same arrangement is throughout the diamond.
Yeah.
Same arrangement is there throughout the diamond.
Okay.
Okay, and only carbons are bound to each other.
Okay.
Okay, so these structures are being asked in the papers many times. I'll take one question and I'll stop for today. Okay.
Okay.
You understood everything? Everything was clear?
Yeah.
Yeah. Okay, so the question says carbon dioxide is a simple molecular substance. Use this information to explain why. Okay, and the question A says sub question, carbon dioxide has a low melting point. We just saw the bonding process. Yeah, the question comes differently only in the exam. Okay, it is not related to the textbook or whatever concept we understand. Maybe you must have an experience with it. Like whatever you study, it comes some higher level only in the exam. Okay, so the thing is carbon dioxide has a low melting point. What will be the reason it is having a low melting point?
Because its molecular structure is like
Okay, let's see. Now see, boiling point and melting point is depending upon the molecular structure. You're right. Okay,
yeah.
but how molecular structure, whether the bond is strong or weak?
Yeah, the structure is weak, so it requires less energy.
Correct. Okay, and less energy needed, so the melting point will be low.
Yeah.
Okay, same for like say this thing. Acetone is a compound. It has a it has a boiling point of 63, somewhat 63, and water has how much? Boiling
100.
point 100 degrees Celsius. That means water has more strong bonds than acetone.
Yeah.
Okay, so that is the reason. So this reason is it. The common error is to state that covalent bonds are weak.